going to talk about the derivatives of function, i.e. the power rule. Okay, so this is number one. Remember, there are a couple ways we can write derivatives. If we have some function with an nth power, n is a real number, right? What's the derivative? Say that again.
N times x to the n minus 1.
Yeah, again. Drop the exponent, subtract 1, right? Okay. Here's another way you can write that same rule. Okay, remember the difference between function notation and what we call Leibniz notation or function. Okay, both will come up. This one has its uses. In implicit differentiation is when I use it more. And it's a little shorter, right? You can just say calculate that and you get an answer. Versus f of x is x to the n. Calculate f prime of x, right? So just know the difference. I'm assuming we don't need any example there. Just because you've seen it before. That just didn't help, did it? Is it better?
There you go.
Okay, where is the tangent line horizontal? Yeah, you got it. Calculate derivative, which is what? Oh, that was easy. And set it equals 0. What does t equal? You're missing one. Yeah, thank you. Remember when you root it, positive or negative? Okay. What's the equation of the tangent line? At t equals 2. Oh. All of antiquity. Search those brain cells. What do we need for an equation? Yeah, we need f at 2, which is and our slope is 0, so right.
So then there's the y minus negative 12 equals 0.
Yeah, if you want, you can write it like this.
Oh, yeah, because the 0, just make it, okay. Yeah,
It's just the y value,
yeah, no.
so
I just did that.
shorter.
Yeah.
I tell my pre-calc kids, maybe even calc, to hang out here, but if you want, that's fine. Okay. Next. This is really difficult. What's the derivative? don't think we need an example for that. The example I had was calculate the equation of a tangent line. So, deep, already good there. Just reminder. A couple of maybe algebra reminders. Yeah, 2. Or you could do the same with natural log of E, right? Anything of the two, the combination of the two, just kind of be able to work those out. Right. Next. That. Oh, yes. When this is going to kind of go back to yesterday, f of x is not differentiable when what did we talk about yesterday? What? Okay, cusp corner. So these are the like I can recognize it more formally, not continuous, right? So f of x is not continuous, or f prime of x is not continuous as well, right? We could prove either of those would show it's not differentiable. Okay. What if f of x is differentiable? What can we say? Yeah. F of x is continuous. Okay. If I remember right, you were pretty good with that last year. Just a reminder.
I learned out a response that said that you had a differentiable function and then it asked if it was continuous or not. That was justified.
Yeah.
Awesome.
Yep. Given f is differentiable, can you apply the IVT? Because f is differentiable, it is continuous, and the IVT can apply, right? Just make sure in some way, shape, or form that you make that connection when you have a statement, okay?
Not the other way around.
We cannot go the other way, though. F is continuous does not mean. Okay, this is called the converse. Put a then here. Is not always true. Okay. And the converse here is just you just flip them. Okay. If f of x is continuous, then x is differentiable. Okay. Not true in this case. Okay. Sometimes it works. Okay. These little things like this are kind of good to know if you're going into maybe computer science, because you can work with these if-then statements, flip them around. The contrapositive, okay, is always true. This is contrapositive. It's a little logic lesson for you. It's always true. Okay. Any guesses as to what the contrapositive is? If f is not continuous, so we take the then statement, we flip it, and we negate them both. Right? So if f is not continuous, then f is not differentiable. Right? That's true. Hey, you just won the lottery. Yeah, I wish.
Don't we all?
Yeah. The lottery ruins most people's lives. True facts. Most lottery winners end up in bankruptcy.
Because they don't know how to spend, because they have so much money.
They don't know how to spend their money right. Can you give me an example of a function that is continuous but not differentiable?
You have to invest all of it.
What? Okay, so yeah, we talked about continuous, not differentiable. Looking at any of these with a cusp, okay, right? What else? Absolute value. Any of the absolute value functions, because they'll always have a corner cusp. Okay, those are the big ones we'll see. Any piecewise functions too. Okay. Some piecewise. So be careful on those piecewise functions. Some of them are not. I think you had one in the homework last night, actually, you identified. Okay, one more example and we're good. Okay, if g of x is x to the 1/3, show g is not differentiable at x equals 0. The book has the limit definition of a derivative on this problem. Okay. What did I show you yesterday that you could do? Okay, that's another option. What's another option? Anybody? Show it's not continuous, right? Okay, so one way is to say g prime of x is not continuous at x equals 0, right? So g is not differentiable at x equals 0. Okay, that's one option. What is the limit as x approaches 0 of g prime of x? What? It does exist. What happens when you put smaller and smaller numbers in a denominator? The denominator gets...
But if you put 0 in there, it doesn't give you...
Hold on a second.
There's going to be 1 over here, and it doesn't fit.
Right.
So
If we analyze the limit,
then it shows that it's not continuous, and you get...
something's not right in my mind here. Oh, of course. Right. If you're approaching 0, you're getting smaller and smaller numbers here. Right. In the denominator, if I I get smaller numbers in the denominator, that makes the whole fraction bigger and bigger, right? So it would tend towards infinity. This, which means not differentiable as well. So you could show the limit as non-existent or infinite. Or you could use the limit definition. That's what your books has. Okay. So lots of ways to do that. Just pick one and go with it. Usually the easiest. Okay. Sometimes this is pretty easy. I would steer you away from the limit definition of derivative, just because it's kind of tedious. All right. You good? You all right there, Dylan? This is due tomorrow. And I'm going to give you another worksheet, but I'll just make it due Tuesday, just to kind of give you some time on it, because it's not really directly applied to this. Work on your understanding of rate of change still. All right. Thanks for remembering stuff.